everyone, today we are going to go through GCSE AQA Physics Paper 2 for 2024. We read all your comments and we wanted to help. Please still revise every topic as no one knows what topics may appear. The timestamps are in the description if you were doing combined, if you want to go over specific topics. And remember, you can also find the copy of this paper. Also remember, during the exam you have the full equation sheet, so hopefully the maths should be easy marks. So let's get started. The visible part of the electromagnetic spectrum from a star includes a dark line. This line is at a specific wavelength. The diagram shows the position of the dark line in the spectrum from the Sun and in the spectrum from a distant galaxy. Explain how the spectrum shift of the dark line supports the theory that the universe began from a very small point. When we look at the light from the distant galaxies, we see the dark lines in the spectrums are shifted towards the red end. This redshift happens because those galaxies are moving away from us, which causes the light waves to stretch out and the wavelength to increase. So this tells us that the universe is expanding. Now let's think about this in reverse. It means that a long time ago, everything in the universe was much closer together, eventually coming from a single tiny point, which supports the idea of the Big Bang Theory. So here in our answer, we're going to talk about the line shifting towards the red end of the spectrum and how the wavelength increases. And this shows that the galaxy is moving away from the Earth. Or if you want, you can say the galaxy is moving away from an initial point. Question B. From data collected, a graph can be drawn that links the speed of a galaxy with the distance of the galaxy from the Earth. So the question asks, how does the visible light spectrum from galaxy A look different from the visible light spectrum from galaxy B? So let's look at galaxy A and galaxy B. So we could see that galaxy A is further away. So if you go down here, you can see that this is telling us the distance, and the distance of A is much more further than the distance of B. So we could say here that light from A has a greater redshift. Redshift tells us how far away it is from the distant galaxy. So the greater the redshift, the further away it is. So here we're going to say that light from A has a greater redshift. A third galaxy, C, seems to be traveling away from the Earth at about 60,000 kilometers per second. So the fact that they give us a number here shows that this is going to be relevant to how we will use it to show on our graph. Estimate how far galaxy C might be from the Earth, showing how you use the graph to do this. So what we're going to do is we're going to go back to the graph, and if we're trying to find 60,000, which is up here, we are going to do a line of extrapolation, which means we're just going to extend the line and see how far it goes. So now that is 60,000, and we're going to take our line down, which is going to be around 3,600. So that is exactly how we're going to do. So the mark number 1 will come from actually showing it on the graph, and the mark number 2 is actually reading it from the actual graph and putting down your answer. Question 2. The diagram shows part of the life cycle of a very large star. Use words or phrases from the box to complete the sentences contained in the diagram. Okay, so the fact firstly, it tells us that it's a very large star. It shows that it's bigger than our sun. So the star is stable, number 1. The star expands to form a, so we know that the first stage is the red supergiant. The third stage is the star collapses. The outer layers explode as is a supernova. So remember, a supernova will explode and make elements heavier than iron and distribute it across the whole universe. Then we have the center collapses further and further until it finally forms a black hole. Number 3, satellites are used to gather data about the origin of the universe, which is basically that everything started from a dense, hot, and small point. The Big Bang Theory is a theory about the origin of the universe. Evidence for the Big Bang Theory is provided by redshift and the cosmic microwave background radiation. Describe what is meant by redshift. So, redshift is basically when light from something moving away from us stretches out, making it look redder. For example, imagine a siren on an ambulance sounding lower as it drives away, and it sounded louder when it was near. The sound wave basically stretches out. This is very similar to when galaxies move away from us. Their light wave stretches out, which shifts to the red part of the spectrum, which tells us that they're moving away. So this tells us that the wavelength increased as the star moves away. Explain how redshift provides evidence for the Big Bang Theory. Now this is very similar to our previous question. So again, it shows that we started from a dense point and now we are expanding. So the galaxy appeared to be moving away. Describe what is meant by the Big Bang Theory. Well, the Big Bang Theory states that the universe started as a small, tiny, very hot, dense point and expanded. If you want to think of it in a different way, you can think of a balloon, and these dots are the different galaxies. Now, if we blow up the balloon even more, you can see that all of these galaxies have become a bit distant from each other. So we all started firstly in this section, and now we're all getting further apart. Question 4. The figure below shows a skateboarder jumping forward off his skateboard. The skateboard is stationary at the moment the skateboard jumps. So now let's look at that wording, stationary, which means the velocity and momentum was 0. The skateboard moves backward as the skateboarder jumps forward. So already here you have these parallel words. So you have backward and you have forward. So there's something that is going to tell us that there's going to be some sort of equal motions. Explain using the idea of momentum why the skateboard moves backward. Now, when the skateboarder jumps forward, they push down and back at the skateboarder. As we can see here, he's pushing backwards. And according to the law of momentum, the momentum before will equal the momentum after, which means the forward push on the skateboard causes an equal and opposite reaction on the skateboard, which is Newton's third law. So for this question, you have 3 marks. So you will gain marks for just stating that the momentum before was 0 because it is embedded into the question that it is stationary. And just stating that the momentum before equals the momentum after is another mark. And the final mark is after jumping, the skateboarder has momentums forward. So skateboarder must have an equal momentum backwards. The mass of the skateboard is 1.8 kg and the mass of the skateboarder is 42 kg. Now, before we move on any further, I think the best way to approach these questions is by drawing some diagrams. So this is the skateboard, which has a mass of 1.8 kg, and then you're going to have the skateboarder, which has a mass of 42 kg. Calculate the velocity at which the skateboard, so we're trying to find here the velocity if the skateboarder jumps forward at a velocity of 0.3. So we know that the velocity here is 0.3. If you can find momentum, then you can rearrange it to find the velocity, because remember, the momentum before equals the momentum after. So we can use this theory to find the velocity of the skateboard. Firstly, what we can do is times 42 by 0.3, which will give us a total of 12.6. So that is the momentum of this section, which is going to be exactly equal to the momentum of the skateboard. So what we can do now is we could rearrange the momentum equation, which we know is the momentum equals the mass over equals the mass times the velocity. So we can now put in these equations. We know that the momentum is 12.6 equals the mass, which we know is 1.8, times by the velocity. So now in order to rearrange for v, we are going to do 12.6 over 1.8, which we get an answer of 7. So the final answer is 7. Question 5. Some students have designed and built an electric-powered go-kart. After testing, the student decided to make changes to the design of their go-kart. The go-kart always had the same mass and used the same motor. The change in the shape from the first design, which is this one, to the final design, which was this one, will affect the top speed of the go-kart. So what we are talking about is the speed. So we want to try to increase the speed. So I want you to imagine this with me. For the first design, what you can see here is that when air particles collide with it, there will be more hitting the surface of the car, so it will make the car go slower. Now, if we go to this design, you can see that there will be less colliding with the surface of the car, therefore it will go quicker. And the term that we use to explain this is that the car is more streamlined. So rather than having this shape, it now has this shape. So the first mark will talk about the design, so it is more streamlined. Therefore, this means that there will be less air resistance hitting the car. As a result, there is going to be a higher speed. The final design go-kart, Y, is entered into a race. The graph shows how the velocity of the go-kart changes during the first 40 seconds of the race. Use the graph to calculate the acceleration of the go-kart. Give your answers to two significant. Now, students usually mess up with the two significant figures, so make sure to underline it, highlight it, so you remember before writing your final answer that you're trying to round it to two significant figures. Now, in order to find acceleration, you're going to try to find the gradient, which in other words is the change in y over the change in x, which is the change in y over the change in x. So what we're going to do here is we're going to go and see the graph. We're going to just draw a triangle so we can see how far it goes. Now you can see that the velocity in this section, which is the y, is going from 5 to 0. Therefore, it has a change of 5. And now we can see that each single line is 1. 1, 2, 3, 4, 5. Therefore, this is 3. So the change for this section is 3. So now let's go back to the equation we said, and we said that a change in y equals the change in x. So if we put 5 over 3, we get an answer of 1.6 recurring. And now remember, it says two significant figures, so we're going to round our 6 up to 7. So our final acceleration is 1.7. Next question. Use the graph to calculate the distance the go-kart travels between point J and K. So to find the distance, what you are going to do is try to find the area of this section, which means we are going to see down where we already said this is 3 and this is 5. So using our math skills, we know that an area of a triangle is half times base times height, which means it will be half times 15, which is 7.5. So our final answer for finding the distance is 7.5, and make sure to put all your working out here. What causes most of the resistive forces acting on the go-kart? As we said in the previous question here, we said that the air resistance is what is causing it. And if you want, you can also mention the wind. The diagram shows a converging lens being used as a magnifying glass. On the diagram, use a ruler to draw two rays from the top of the object, which show how and where the image is formed. Represent the image by an arrow drawn in a correct position. So first thing you're going to do in this question is you're going to draw a horizontal line from the top of the object. The next thing you're going to do is pass that line to the first focal point, which is here. So we're just going to extend a line through the focal point. Next thing we're going to do is from the object, we're going to extend the line through the center. And now you're wondering what we're going to do next. Well, you can see that these 2 points don't meet. Therefore, they're going to go to the opposite direction. So we're going to extend it. It isn't exactly perfect, but that is basically what it is. And now because you can see that there is a intersection, you are going to draw your new formed image. Use the equation in the box to calculate the magnification produced by the lens. Show clearly how you work out your answer. So in order to answer this one, what you are going to do is you are going to grab your ruler and you're going to place it on your image height and your object height, and then you are going to divide it by each other. It won't be necessarily correct in mine, but for example, mine's is 4 and this is 2. I am just going to be dividing the 4 by the 2 to give me a magnification of 2, but it will be much more accurate when you're drawing it on paper. Question number 7. The speed of light is 3 times 10 to the power of 8. The wavelength of yellow light is, as said, calculate the frequency of yellow light. State the unit. So frequency is the speed over the wavelength. So what you're going to do is you're going to plug in the numbers. So we have the speed, and then we also have the wavelength. So simply put them in the equation, and you can easily get the answer. And therefore, the answer is going to be 5.2 times 10 to the power of 14. And now, don't think that you are done. They tell you specifically to state the unit. And remember, the unit for frequency is the hertz. So it will be 5.2 times 10 to the power of 14 hertz. And that is our final answer. Question 8. Ultraviolet waves are useful, but they can be dangerous. State 2 uses of ultraviolet waves. Well, number 1, you're able to kill bacteria during water purification. You can also use fluorescent lamp, example for tanning machines. I'm sure many of you have heard of tanning machines that use ultraviolet waves. Other examples could also be security markings and also medical uses. State 2 dangers of the ultraviolet waves. Well, number 1, they can cause cancer because they are ionizing. And secondly, especially when using it for tanning machines, they can cause sunburns. Other answers also include eye damage or blindness and skin aging. Question 9. The figure below shows 2 students investigating reaction time. Now, for those of you that do biology, reaction time is one of the practicals, so hopefully you remember that. Student A lets go of the ruler. Student B closes her hands the moment she sees the ruler fall. The investigation can be used to find out if listening to music changes the reaction time. Explain how. So, firstly, you want to be talking about measuring the distance the ruler falls before being stopped, and you're going to repeat this multiple times. Then, as it tells you to explain and not describe, you need to be saying that the longer the distance fall, the greater the reaction time. Now you're going to repeat this several times with the student listening to music. And of course, in every experiment, you want to be calculating a mean. This is a very important point. A difference between the two means would show that the music affects reaction time. So you can say comparing it on a graph, comparing it on a table, etc. 10. A microphone is connected to an oscilloscope to display a sound wave. The diagram shows the trace on an oscilloscope screen. Now, I just want to clarify a few things. Now, we know that a sound wave is a longitudinal wave, so don't get bogged down by the fact that this shows a transverse wave. When the wave is being shown on an oscilloscope screen, it tends to show a transverse. The oscilloscope settings are y direction 1 squared equals 1 volt. So we can say that this is 1, this is 2. X direction 1 square is 0.001. So here we have 0.001. How many time periods are shown on the trace? So for the time periods, you're just going to go on your graph and you're going to see how many times the wave is recurring. So that is 1, that is 2, and that is 3. So there are 3 periods shown on the trace. What is the frequency of the sound wave? So in order to find it, you are going to see how long it takes it to go from, to make one wave. And then you're going to divide it by 2. So you are going to firstly find that the y direction is going to be 2. This direction, the x direction, is going to be 0.002. Now dividing them together, you're going to get an answer of 1000. And now you want to divide it by 2 in order to find one full turn, and that is going to give you a frequency of 500 Hertz. On the grid below, sketch the trace of a sound wave with a smaller amplitude and a higher frequency. So a smaller amplitude has to be a lot more below it, so it has to be something like that. And a higher frequency means that there is going to be more lines, something like what I am showing you. So in order to get that, we need to make sure there's a lot of lines, but it is still under these points, which will show it has a smaller amplitude. So it would look something like this. Make sure it can be as accurate as possible. Question 11. State 2 properties of electromagnetic waves. Well, the EM waves, remember, are transverse waves and they travel in a vacuum. So what exactly does a vacuum mean? It means that there is no matter. For example, sound waves, they have to travel in matter. They have to travel in a solid, in air. But electromagnetic waves travel where there is no air, where there is no matter. Other properties you can state is the speed. You can say it has a speed of 3 times 10 to the power of 8 meters per second, and you can also say that it transfers energy. Next question, how do infrared waves differ from ultraviolet waves? So let's look through all of the answers and see which ones make sense and which one doesn't. So A, infrared waves are longitudinal. We know that is incorrect because they are all transverse. Infrared waves have a lower speed. Nope, they all travel at the exact same speed of 3 times 10 to the power of 8. Infrared waves have lower frequencies, and infrared waves have smaller wavelengths. So as you can see here, I have drawn for you the electromagnetic spectrum. You can see that the ultraviolet side have a higher frequency but smaller wavelengths. So this means C is the correct answer because infrared waves have lower frequencies. In this diagram that I am drawing for you, these 2 points are the wavelengths, and the closer they are, the higher the frequency. So the fact that the wavelengths in the infrared section is further apart, it means that it has a lower frequency. So indeed, C is the correct answer. Question number 12. The picture shows 2 teenagers riding identical skateboards. The skateboards are moving at the same speed and the teenagers have the same mass. Why do the teenagers not have the same momentum? First thing, remember that a momentum is a vector quantity, which means they have to have direction. So you can tell that both of them are going in different directions, so they have different momentum. One of the skateboards slows down and stops. The teenager then jumps off the skateboard, causing it to recoil and move in the opposite direction. What is meant by the momentum being conserved? Well, what we can say here is that the momentum before is equal to the momentum after. These are really easy marks that you can gain, so make sure to know that this is the rule. Momentum before is the momentum after. The teenager of mass 55 kg jumps off the skateboard at 0.4 meters per second, causing the skateboard to recoil at 10 meters per second. Use the equation in the box to calculate the mass of the skateboard. Looking at our rule before, that the momentum before equals the momentum after, and they tell us that the momentum is mass times velocity, so we can say that the mass of 1 times the v of 1 equals the mass of 2 times the v of 2. Now let's just plug in the numbers. So we have the mass of 1, which is 55 times 0.4 equals something times 10. Now, easily we could rearrange this equation. So, firstly, let us find 55 times 0.4, which is 22. 22 equals something times by 10. 22 over 10 equals something. So, the mass is 2.2. And that is the final answer. Next question, once the skateboard starts to recoil, it slows down and its kinetic energy decreases. Explain why. Now, when it tells you that there is kinetic energy, you are going to be talking about work being done. I'm going to draw you here a diagram. This is the skateboard and this is the ground. You can tell that there is going to be some sort of friction between the skateboard and the floor. So work is done against friction, which basically transforms kinetic energy into heat. For example, if you rub both of your hands together, you can say that work is done and friction is happening, and you can actually feel that your hands begin to feel warm, and that is exactly what is happening with the skateboard and the floor. Question 13. Figure 8 shows a force of 70 newtons turning a lever about point P. Calculate the moment of the 70 Newton force about point P, and we're going to state the unit. And I'll give you a really easy way to remember and know how to do the unit even when you don't actually know it. So they give us the equation here. We have to find the force and the distance. Usually it will be the perpendicular distance, so as you can see they did put us the right angle, so we are trying to find 70 newtons. So we're going to just put them all into the equation. So 70 times by 0.4, which is equal to 28. Now as you can see it is 3 marks, so just putting 28 is just going to give you 2 marks. And now we need to make sure to find the unit. Well, if we know that the unit for force is Newton, and we know that the distance for the normal is meter, you can literally put them together. So they will make Newton meter. And you can actually see that they're being times together. The N is being times by the M. They're not being divided. If they were divided, you would say it's newtons per meter, but because they aren't, you're going to just say it's Newton meter. Figure 9 shows a worker using a wheelbarrow to move some sand. The load is equal to the total weight of the sand and the wheelbarrow. The effort is the force that the worker applies to the wheelbarrow handles. The worker applies just enough effort to lift the load. Explain why the effort is smaller than the load. In this diagram, when you're using the wheelbarrow, the effort needed is small if you push far from the pivot. This is because a small force applied far from the pivot creates a big turning force, which we call the moment. This big moment can lift a heavy load that's close to a pivot, so using a wheelbarrow with a long handle will make it easier to lift things with less effort. This means the effort is at a bigger distance from the pivot. And remember that just saying from the pivot will give you another mark, and that will be 2 marks. Some sand falls down and sticks between the wheel and the axle. State why it might be harder to push the wheelbarrow along when there is some sand in between the wheel and the axle. For this answer, there will be more friction between the axle and the wheel. Forces have different effects. Use the correct answers from the box to complete the sentence. The moment of a force is well, we know that the moment is the turning effect. What is meant by the center of mass of an object? Well, for example, here if we had this square, you can say that the center of mass is exactly where it lies in the midpoint. So the point at which mass may be thought to be concentrated. So all of the mass in this example will be concentrated in the center. Some children build a seesaw using a plank of wood and a pivot. The center of mass of the plank is above the pivot. Figure 1 shows a boy sitting on a seesaw and his weight is 400 Newton. Calculate the anti-clockwise moment of the boy in Newton meter. We know that his weight is 400 Newton, so in this case it is going anti-clockwise. So you can imagine this. This is the pivot and this is the seesaw. So the person is going to go to the other side. So what you're going to do is you're going to do 400 times 1.5, which is 600 Newton meter. Figure 2 shows a girl sitting at the opposite end of the seesaw. Her weight is 300 Newton. The seesaw is now balanced. The children move the plank. Its center of mass M is now 0.25 from the pivot as shown in figure 3. The boy and girl sit on the seesaw as shown in figure 3. Describe and explain the rotation of the seesaw. So in this question, they are asking us to see whether it's going to go anti-clockwise or if it's going to go clockwise. We know that this guy is 400 Newton and we know that this girl is 300 Newton. So if you want, you can carry out a quick calculation. So we saw that this one is 600 and this girl would be also 600. But because the center of mass is closer to her, this means it is going to go clockwise. So here you're going to say that the plank rotates clockwise. This is because the total clockwise moment is greater than the anti-clockwise moment. Therefore, the weight of the seesaw provides the clockwise. Next question, the boy gets off the seesaw and a bigger boy gets on it in the same place. The girl stays in the position shown in figure 3. So this girl stays in the exact same position. The plank is balanced. The weight of the plank is 270 newtons. Calculate the weight of the bigger boy. Well, the fact that they say the plank is balanced tells us that it is exactly equal. So in this question, they're telling us that this boy is off and the other boy comes and sits in the same position. And our job is to find the weight of this fellow man. We could do the weight times by the distance, which is 1.5, and because the plank is balanced, we're going to equal it to 270 times 0.25 and add it to the girl, which is 300 times 0.2. Now, if you're wondering why I did 270 times 0.25, well, we know that the weight of the plank is 270 and the center of mass is 0.25, so you're going to times it together. So this means W times 1.5 is 667.5. And in order to rearrange it, we are going to do 667.5 divided by 1.5, which is going to give us an answer of 445 Newton. Question 15. Figure 1 shows a portable power supply. The portable power supply has an alternator connected to a transformer. The transformer can be adjusted to have different numbers of turns on the secondary coil. Suggest why. Well, if you think about this in a normal day-to-day life, different devices will have different amounts of potential difference that it can handle. So, if it has different numbers of turns, this means it will vary the potential difference. And this means that you don't need a different generator for each type of device. So for example, you can use it for your phone, or you can also use it for your iPad or laptop. Next question, a lamp is connected to the power supply. The lamp requires an input potential difference of 5 volts. The alternator generates, now let's just highlight generates, which means it is the one that is giving in, inputting a potential difference of 1.5. The primary coil of the transformer has 150 turns. Calculate the number of turns needed on the secondary coil. So the equation for this is the PD in the primary over the PD in the secondary, which equals the number of turns in the primary over the turns in the secondary. Now let's just input all of the information we know into the equations. So it generates, therefore it has an input of 1.5 over 5 volts, which it gives in, and that is going to be equal to 150 turns over what exactly we're trying to find, which is X. Rearrange for X. So X is going to be 150 over 1.5 divided by 5. And this means X is equal to 500. So it has 500 turns. Next question. Figure 2 shows the inside parts of the alternator. So we can see here that it has a slip ring. And when it has a slip ring, it is going to be the generator effect. The handle of the alternator is turned, causing the coil to rotate. Explain why an alternating current is induced in the coil. Let's look back at the diagram. Well, remember that when you go from north to south, there is going to be a magnetic field. And also in the coil, which we have over here, there is going to be a magnetic field around it, which means that the two lines, which I've represented in blue and red, are going to cut the magnetic field lines. This in turn induces a potential difference. And remember, because it is a complete circuit, there is going to be a current induced in the coil. This so far will give you 3 marks out of the 5 marks we are looking for. So you might be wondering, what are the 2 final marks? Well, the 2 final marks tells us that every half turn, the potential difference will reverse the direction. Because as you can see, the slip ring will push it to one side, stop, and go to the other side. This means every half turn, the current will change direction. Therefore, an alternating current will be induced. This is exactly how you need to go step by step if you would like to screenshot this. I would definitely recommend you to memorize word by word because this is very frequent questions that may appear. Suggest the purpose of the slip rings. Well, the slip rings will help to provide a continuous connection. Now, there's also another one called the split ring. Well, you could literally tell that it is splitting, so it won't provide a continuous connection. This means it will stop the wires from twisting together because, as you can imagine, these wires, if they continue to rotate, they will eventually tangle over each other. The alternator from the portable power supply is disconnected from the transformer and lamp. Explain why the handle of the alternator becomes much easier to turn. Well, number 1, there is no induced current. Therefore, there is no magnetic field. Whenever you talk about current, it is usually going to be followed by something about the magnetic field. That is usually the pattern. It will oppose the movement of the coil. Question 16. A man pulls a suitcase with a horizontal force F as shown in figure 10. 2 other forces acting on the suitcase are labeled P and Q. Which of these give the correct names for the force P and Q? Well, we know that force Q is the friction. So this side is going to be friction, while P is the normal contact force, which is perpendicular to the ground, which we call the reaction. So the answer for this is going to be B, reaction and friction. Draw an arrow on the diagram to represent the weight of the suitcase. Well, the weight is going to be what is being pushed downwards. So you can already tell that it will be a vertical arrow acting downwards through the suitcase. So something like this. A man pulls the suitcase for 80 meters along a horizontal path. The mass of the man and the suitcase is 85 kg. The man does 1,200 joules of work on the suitcase as he pulls the suitcase along. He walks an average velocity of 1.5 meters per second. Calculate the kinetic energy of the man's suitcase. Now, kinetic energy is actually featured in paper 1 more than it is in this. However, you are still required to know that, and it is very good that you were given the whole equation so you can just see it. So you want to do half mv squared, and you are just going to input all of these. Half times 85 times 1.5 squared, which is going to give you an answer of 96 joules. Calculate the horizontal force that the man exerts on the suitcase. Use the equation. Work done equals force times distance moved in the direction of the force. So we're just going to take all of the information we have, and we want to firstly rearrange it to make it force equals work done divided by the distance. And now we're going to input all of the numbers. So work done we have is 1,200, and the distance we have is 80 meters, which means the final answer is 15. The man runs up a set of stairs carrying his suitcase. Explain whether he does more total work if he walks up the same stairs instead of running. Well, for this one, the work done is the same for walking and running because the work done depends on force and distance, not time. So make sure to specifically say not time. So it will only be dependent on the force and the distance. The man lifts his suitcase. The increase in gravitational potential energy of the suitcase is 264 joules. The mass of the suitcase is 12 kg. Calculate the vertical height the suitcase is raised. And they give us the equation, which is mass times the gravitational times the change in vertical height. So what you're going to do is you are going to rearrange it to find the height, which is going to be change in the gravitational potential energy over the mass times g, which is the height. So it is going to be 264 over 12 times 10, which is equal to 2.2. So your final answer is 2.2 meters. The diagram shows a bar magnet. Complete the diagram to show the shape of the field around the magnet. So as you can see, this is going to give you 2 marks. So the first mark is drawing the lines, and the second mark is drawing the correct arrows. So first let's draw the lines. It's going to look something like this, and you're going to do the same for the other side. I would recommend you do around 4 lines. And remember, it goes from north to south. So we got our first mark, and now we need to do the correct arrows, so north to south. So it's going to look something like this. Final question. The graph shows how the vertical velocity of a parachutist changes from the moment the parachute jumps from the aircraft until landing on the ground. Using the idea of forces, explain why the parachutist reaches a terminal velocity and why opening the parachute reduces the terminal velocity. Now, this question is indeed one of the questions that repeat every year, so it could easily be in the paper. So as it gives you a graph, it is most likely that these 6 marks are going to ask you to add some sort of numbers. So it's very important you look and interpret the graph correctly. Now, the second that the skydiver leaves the plane, the only force that is acting is the weight. So if this red dot is the parachutist, the only resultant force is the weight. There is no other acting on. And remember, when there is a resultant force acting on a section, this means it is accelerating. Okay, so as the parachute falls, air resistance will act upward, and the weight is going to be greater than the air resistance. And you can also say that there is going to be a resultant force downwards. So this means the parachutist will continue to accelerate. And as velocity and speed increases, so does the air resistance. And where we see the line becoming constant, this is what we call the terminal velocity. Now, you can directly see a very drastic deceleration. And why is this? Well, you can see in the diagram that the parachutist opened their parachute, which increases the surface area. And increasing surface area means there is an increase in air resistance. Therefore, if we draw our diagram again, we can see if this is the parachutist, there is going to be a resultant force upwards because they are going up due to the air resistance. Therefore, the parachutist decelerates and slows down, because imagine the parachutist without the parachute, they are going to collapse on the floor and die. So it is very important that there's an increase in the surface area so they can decelerate slowly, and this in turn will make the weight equal to the terminal velocity, which we call equilibrium. So this is exactly what you want to be including in your 6 markers. So if you want, again, take a screenshot of this, memorize it. It could possibly come up as a 3 marker, maybe a 4 marker, or maybe a 6 marker. And that concludes the paper. I hope this was helpful in your revision. For many of you, this is your final exam, so make sure to try your hardest and give it your all, and hopefully you will be proud on results day. Good luck to everyone, and please do come back and let us know how the exam was in the comments.